Hopefully the third and final video, we're going to do the rest of the examples in exponent form or exponential form. You can see it either way. We're going to rewrite. Now we have the root. That's our root. And that goes under the ground. So we just rewrite this as x to the power of 5 over the root, which is 3. And that's it. So x to the 5/3. There's not much to that. One thing that students tend to get confused on is when they see 2 or more factors under the radical, they don't rewrite both of those factors to that same exponent. So we're going to write it in exponent form here, but we're going to simplify that a little bit as well. We know that when, like there's an extra little rule that we are supposed to know that a times b to the m, let's say, is equal to a to the m times b to the m. So that exponent has to be, it's kind of like distributed to both of the factors inside the parentheses. And so here we see an a squared to the 1/2. So we have a squared to the 1/2. And then we also have b cubed to the 1/2. And now a squared to the 1/2, we multiply. 2 times 1/2 is just 1. So I could put a 1 there if I wanted to. 3 times 1/2 is 3/2. And so just cleaning it up without that 1 right there, we can write it as a times b to the 3/2. That would be the simplest way to write it in exponential form or exponent form. I really don't like the term exponential form, but anyway, that's how we do that. For the 8th example, and there is one last page here for 9 and 10, we have the cube root of a bunch of stuff. And so we know that that means that we have all that stuff raised to the 1/3 power. Remember, we have all this stuff to the first power, and then we have the root being 3. So the 3 is downstairs, and if there's no other variable up there or exponent, we just have a 1. So we have a to the 5th, b to the 3rd, and then over c squared all to the 1/3. So that means that all 3 of those get raised to the 1/3 power. So a to the 5th, b cubed, and as well as c squared get raised to the 1/3 power. And then again, when we have power to a power, we multiply. A to the 5/3 times b to the 3 times 1/3. That's 1. So I guess I'll write it. And then we have c to the 2nd power to the 1/3. So we multiply 2 times 1/3, and that's 2/3. So that's right there. That is exponential form. And as ugly as it is, that's where we're going to stop. That's it. That's our answer. Exponential form. And then on the last page, we have probably the most detailed examples, and so you definitely need to know your properties of exponents. And we have 2 terms here that are going to be multiplied together, and they don't have the same root. So write in exponential form. So we have to do that first. So we take 8 and write that as radical 8 is 8 to the 1/2, and we write cube root of 4 as 4 to the 1/3. Now, 8 to the 1/2, noticing that 8 and 4 can be written as powers of 2. Now that's critical to remember that, because if you can't write those as a power of the same number, same base, you can't combine them. So normally when you see a problem like this, you'll be able to write both of the bases as a power of the same number. So when I say that, I mean 8 can be written as 2 to the 3rd, 4 can be written as 2 squared. Since 8 was raised to the 1/2, 2 to the 3rd will be raised to the 1/2. 4 being raised to the 1/3, 2 to the 2nd power is raised to the 1/3. And now we can write that as 2 to the 3 times 1/2, that's 3/2. And here we have 2 to the 2 times 1/3, which is 2/3. So now when we have 2 bases that are the same, like using this property right there, when the bases are the same, what do? We add the exponents. So we have 2 to the 3/2 plus 2/3, and now we have to get a common denominator. 3/2 plus 2/3 is 3/2 times 3 top and bottom, and here we get a common denominator 6. 2/3. We multiply top and bottom by 2, and we get 9 over 6 plus 4 over 6, so we get 13 over 6. So it even gets better because 2 to all of this stuff is 2 to the 13 over 6. So that right there is our exponential form. And then, so that check for that one. And then we need simplest radical form. So let's take this and go over here. And we have 2 to the 13 over 6. That's the same as the 6th root of 2 to the 13th. And in the past, we had moved that power to the outside of the radical, but we don't want to do that this time. We now look back at this as this is like Go Fish. This is like the card game that we played the other day. So the 6th root of 2 to the 13th is the 6th. We're looking for groups of 6 2's. We have 13 2's, so we can break it down into 6 2's there, another 6 2's there, and then one more 2. So if you remember what we did, we said, okay, we need groups of 6, books of 6, and we have a book of 6 2's. We have another book of 6 2's, and we have just 1 2 underneath. And so we end up getting 2 times 2 on the outside times the 6th root of 2, and that means we can multiply the 2's together. 2 times 2 gives us 4, and then multiply by the 6th root of 2. So that right there is the simplest radical form. And that's kind of a cool problem, because if you can do that problem, you can do any of these. And I will take one more video to do the example number 10.